except that ended up being the thumbnail. And so like a picture of me getting Diet Coke was on my like front was on time.com for
I
like
mean, that's representative of a non-trivial amount of time that Facebook as a company is
me getting Diet Coke. Yeah, I know it's pretty accurate.
I'm working on a small client. Right now, working on content generation. Putting things up is like a feather in the more. So like a simple network interface. So are you familiar with so taking network interface and taking it out of have an interface that you can swap out.
So I was talking with them. As it turns out, they don't have Windows installed, so you're gonna have to do it. This is Lee's entry into the deck that would be most useless if posted to Speaker Deck contest.
I don't post my decks.
It's very good.
Totally useless. Like the set of slides don't actually correspond to like
Just talking about
The set of slides.
presentation.
The set of slides correspond to when it was most convenient to switch to a new slide to make magic work.
Yeah. At least in this deck, it's very true.
Like I've definitely had a couple times where like I needed two things not to be grouped so I can do things on them, but then they needed to be grouped for the magic move. And so it's just like, guess there's just like a duplicated slide in here where I ungroup and it automatically advances.
Yeah.
Okay.
I'll also, for like real conference presentations, I like write out a script.
Yeah.
I want to say first. And sometimes when those line up to get slide, yeah, there'll be like a bunch of animation tagging in one thing with like a paragraph of text.
Yeah.
And then all of a sudden I'll cut to another slide or like one small animation happens just so I can like kind of go into another script note.
Yeah.
Hey everyone, we're gonna get started here in about 3 minutes, so if you could grab a drink, take your seats. I'll be back to join you shortly.
It'd be pretty funny if the password was actually no password.
just had a conversation with Josh about GraphQL
So I don't want to do that. I don't want to go to the stack.
times that
Where basically they're like, can we do this?
No, they're already messing around with it. Not necessarily shooting it as much, but doing normalized response so that the server will flush incrementally as it plays. They're just kind of prototyping that. Seems like it's cool. It's in the mind space. It's happening.
Should be doing prototype.
Did you catch the GraphQL team start at all?
What bud?
Jan kicked off.
Yeah,
He was basically talking about like graph mode as a way to deal with fragmented alias stuff. Take a look at it.
Graph mode has some pretty interesting implications on like two sub-branches that in non-graph mode would overlap, but now do overlap. So like if your client expects graph mode, then it probably already is accounted for that.
You end up with a conflicting answers.
Conditionalization.
I'll get you on in a second.
So like really,
Yeah.
yeah.
Hey everyone. Oh, sound. Yeah. Yeah. Hey, everyone. We're going to start off here. First of all, I want to welcome everyone to GraphQL SF, and also hello to everyone who's joining us on the live stream. We've been running this meetup, I think, since last May, and this should be the 5th meetup, so it's kind of a little bit over a year since we initially started. I'm Tay Lampkin. I work at Apollo on dev relations and community stuff, and I've been kind of seeing this meetup along the way. So yeah, it's been a really exciting time. I actually went through a lot of our intro slides for some of our first meetups and discovered this one, which was, I think, our second ever meetup, where we were really excited about the growing GraphQL ecosystem and lots of the open source libraries popping up and kind of beginner services that were helping people get started with GraphQL. Since then, a lot has happened. And so today, it's been kind of a whirlwind couple last months. Shopify released a beta version of their storefront API in GraphQL. Apollo Client hit 1.0. Relay Modern was also released shortly thereafter. Yelp launched their local graph API, which was in GraphQL. We had the second ever GraphQL dedicated conference in Berlin, organized by GraphQL, a backend as a service GraphQL company. And GitHub launched their 4th version of their API, also in GraphQL. So yeah, lots has happened. That was kind of like one of the reasons we decided to make this meetup not really themed, but all about everything awesome that's been going on. And on top of that, we just announced GraphQL Summit, which you've probably been seeing on these intro slides, which is our second conference in October. And now there's a lot more to talk about, so we're going to do 2 full days, 1 track. And if you have any GraphQL stories to share, please apply to speak. We haven't released any tickets yet, so follow us on Twitter or just sign up for the newsletter so you can be the first ones to know when we release those early bird tickets. And yeah, the interesting thing is I saw a lot of new faces on the RSVP list to the meetup, so I wanted to kind of get a temperature of the room, like how many people are actually using GraphQL. So who's never used GraphQL before? Awesome. Okay, who's stood up their first endpoint? And who's using GraphQL in production today? Cool. So in case you need more beginner resources for GraphQL, or anyone listening along in the live stream needs it too, here are some really great resources to start with, maintained by both people on the GraphQL team and just people in the community. And yeah, so I'm really excited about what we have for you today. We're going to start off with Yelp. Tomer Elmalem, I hope I got your name right, is going to talk about Yelp's new public API. And then we're going to hear a little bit about how Airbnb are using GraphQL. We'll take a short break, and then we'll hear from Lee Byron on subscriptions, the latest feature to make it into the GraphQL spec. So without further ado, here is Tomer. Yes.
As soon as Google Slides starts working again. There we go. Yeah, I've got this awesome pun that somebody at work decided was hilarious. Yeah, so my name's Tomer. I'm an engineer at Yelp. I spent the past 2 years working on a public API and the past couple months building out GraphQL for a public API. So we'll walk you guys through some of the stuff we've been doing. So our mission is to connect people with great local businesses. One of the things I do on the public API is wanting to expose that same functionality to our developers and partners. So wanting to let people embed things like business search into their applications. So in the beginning, we had this kind of old API. It's the same story you've heard before. We had a few massive endpoints. This is actually me scrolling through the response. It just keeps going and going. So we decided we didn't really like this, and we decided to build a new API. So we built what we called V3, the Fusion API, and it was great. It was modular, it was super RESTful. And then people started using it, and they were all happy with it, but people kept asking us for more things. People just kept being like, I want this one attribute and this one endpoint, I want this other thing here. And I didn't really want to get back into that. It was not, I didn't want to repeat the mistakes of the past, so it's kind of where GraphQL came in. I won't really get into the nitty-gritty of like the specifics of why we did GraphQL. I think most people probably understand that it makes your API a lot more flexible. It's a lot easier to use for nested resources. But what I will touch on is that it works really well for our data. Our data is very well structured. Businesses have reviews. Reviews are written by users. Users check into businesses. All of the data is highly relational, so it all fits really well into this idea of a graph. So this is kind of our setup at a high level. We have a dedicated service that runs just the public API. The public API ecosystem is Python 3.6, so it's the public API service, it's the OAuth service, and it's our front end that exposes GraphQL in our documentation. We run Graphene, which is written by Cirrus. The service itself runs off of Pyramid New Whiskey, and if you're not familiar with Pyramid, it's Python's version of Ruby Sinatra or Node Express. We have a pretty complex microservice architecture. Right now, we've got over 200 services in the entire Yelp ecosystem, so we rely on that pretty heavily. And our public API actually has no database attached to it, so there's no data store that goes into it. So I'm going to focus on the first couple points, how we basically built out GraphQL with Python. So this is a pyramid view. It's a simplified version. It's missing a few things like checking if you're in the beta, request decoding, rate limiting, stuff like that, but it kind of gets the idea across. So the first interesting thing is this decorator. If you're not familiar with Python, a decorator is effectively a function that wraps the execution of another function. This specific decorator just checks the API access just to make sure your request is authorized. The decorator looks like this. This isn't strictly for GraphQL, but I'll dive into why we need to know this a little bit. At a top level, it's pulling the access token from the header, it's validating the token against the OAuth service, and if everything works, it's injecting the client back into the request. So this specific line is the GraphQL view I showed you before, just to give you a sense of what it means when a decorator wraps a function. So going back to the view, next up we have the schemas. So we instantiate the schemas. The query class defines a couple top-level fields that we're currently exposing. There's nothing too special going on here. We expose business lookup, we expose search. There's another 12 attributes to search that I just couldn't fit. And then there's also phone search and loading reviews. So business lookup, just given a business alias, return a business schema. Nothing too exciting there. The business resolver itself lets you load the business that you requested. So if we start at the top, we have another decorator here. So this is the same decorator as before with one small difference. We're imposing slightly different access control limits on GraphQL, so we do need to verify that people are not doing anything too crazy. So we'll just check the client against the GraphQL access. We built everything as a service, so we end up calling into a lot of other services for all of our data. Our entire GraphQL API is actually making service calls to load and aggregate the data. This specific bit is instantiating our internal API client library and then making a request into internal API to convert the business alias into our internal representation of business IDs. Oops. And then lastly, once we've made the request, we queue up the data loader. The data loader does something interesting here. Without me having to instantiate the business schema itself or tell it what is actually going on, it can actually infer the schema, instantiate the object, and populate the data based on the declaration I had earlier. So back to the view. Next up, we have the context. The three things we want to give to all resolvers are the request object, the client that's attached to the request, and all the data loaders we have available. So the request object maintains kind of what you'd expect. It has things like the HTTP method, the IP, the headers, any metadata we collect from our CDN. We use this from anything for IP-based rate limiting to localization to just straight up debugging. The client contains things like the app name, how many requests they've made, and any special access they might have. And lastly, we just have the data loader mapping, just so that the resolvers know what data loaders are available. And this is actually just a pretty dumb class. It's not doing anything special. It's mapping the actual data loaders and instantiating them to what we want to call them for all the resolvers. So what does the data loader actually look like? All in all, it's not doing anything too crazy. The batch load function is the function you need to override to handle actually the batch loading. It'll give you a list of all the IDs based on what you call them. So where do all these IDs come from? If we go back to the business resolver, the .businesses.load business.id is what's actually aggregating all of those IDs for the data loader itself. Every time you call it, it starts saving the business IDs, and then when you need it, you can kind of go back in the data loader, and it gets passed in as the business IDs up top. So we can then pass that straight into the internal API call, and that's just, in actual Python, it's a tuple, so you don't have to do any modifications on it. The get businesses info call is a bulk endpoint we created to bulk load the businesses. The data loaders in combination with the bulk endpoints is how we got around the N+1 problem that a lot of people face when they're working with GraphQL, and this made it pretty easy to work with. The last thing is all the data loaders have to return a promise. The promise will just be the resolved object that you get back from whatever you're using as the data store. This needs to be a list so that the data loader can actually map back to the load call. So now that everything's actually set up, we can actually execute the query. So we go back into the business resolver, it gets the business ID, passes that back into the data loader, and we get to the business schema. So business schema is doing that same business.load that we did earlier, but it's not actually making another network request because it's been cached. So that's kind of the nice thing is that, yeah, the data loaders do caching for you, so if you've already returned the data for a specific ID, it's not going to make another request. The reviews resolver here is a little special. The reviews resolver has to use a different data loader because it comes from an entirely different service. So we have to call that separately. There is one small caveat with the reviews resolver, and that's we don't know how many reviews we're going to get at any given time. Review counts change pretty frequently, so we can't hard code this. What that means is we have to wait for the data loader to make the request and resolve and return us the data before we can actually build the reviews. So once we have all the reviews, we'll call this def build function, build reviews function, and it'll go through the reviews and actually set up the list. Just a quick side note, if you're not familiar with Python, inside the build reviews function, what the return call is doing there is a list comprehension. It's just an iterator that does an in-place build for lists. So if we step back a little bit, this is kind of what it looks like visually. You start with a query, comes into the view, gets parsed, gets passed into the business schema. All the resolvers go into the individual data loaders, and then all the data loaders hit their own services. So this is kind of a good transition back into what the actual service architecture looks like for us. So GraphQL and microservices actually work really, really well together, and I was pretty happy about this because that's how we do everything. Data loaders enforce a pretty clear separation of owners. Each service is responsible for one type of data, as is the data loader itself. There's geolocator service, we have the photo service, we have the OL service, we have the review service, so on and so forth. Each data loader will make a request to that individual endpoint so that we know the data loader is only doing one thing. Since each service does expose its own API and we're only going to be working with one specific endpoint, we do have a very granular level of control over what's going on, which means we don't have to worry about pollution anywhere or anything like that. The other thing is the granularity gives us a lot of flexibility into how we actually can do query planning. So if we need to defer the execution of the photo service until the review service finishes for whatever reason, we can do that. If we need to wait on both services until OAuth finishes, we can do that. It's become a lot easier to do when we can tell each individual data loader to wait on something else. The other thing is it made failure handling and retries a lot easier. The data loader failing in one specific case doesn't impact any of the other data loaders, which is really nice. Having a data loader continuously retry while the other data loaders are kind of doing their own work has been really nice. It just made the execution of how we ensure consistency a lot easier. Parallel execution is also really nice. It's not quite doing full async. If you can think about it this way, we might have service A, which we can't make 20 QPS against, but we can do that against service B and against service C. So on service A, we can sequentially call 20 times, but we don't have to block the calls on service B and service C. So we have some combination of an asynchronous fan out while still having blocking calls, but we don't have to block on the entire service call. The other two things that we get are service caching and request budgeting. So we have a service we actually launched about a month or two ago called Spectre. It sits in between all of our network calls, and it's effectively just a generic caching layer for all services. It can be applied to any service at any time without needing to change any of our code. It's pretty invisible to the service call itself. All you really need to do is make a couple config changes. On our side, the service discovery tool we use, SmartStack, if anyone's familiar with it, knows to automatically go to Spectre for the cache or knows to bypass it. So Spectre itself has pretty granular configuration, meaning that we can set up its own caching strategy, we can set up its own TTL, we can set up its own invalidation if we need to. This is pretty great for us because some data we want to cache for longer than we want others. In a specific example, it's okay for us to cache business data for 1 or 2 or 3 days, but user data we probably want to refresh every hour because if someone's actively checking in or writing reviews, we want to be able to get that to them quickly. So this separation has made it easier for us to actually control caches so that we're not unnecessarily overwhelming any services. We can still pull fresh data without having an impact on the end user experience. So this is kind of what it looks like. I realize that's actually really small now. So yeah, the top's just regular request, data loader goes straight into the service, gets a response back. The middle one is the cached service call. So data loader starts making a request into the service, Spectre sees the request, intercepts the request, and then returns the cache response. The bottom one is what happens if there is no cache. So Spectre intercepts the request, sees there's no cache, lets it go completely to the service, and then the service can respond with the response itself. And at that point, Spectre can cache it. So next up, we have this idea of a request budget. So built into how we make requests is this kind of idea of budgeting. An external request is allocated a total time budget to execute round trip. What this means is you have one request coming in, and internally that could be 5 or 6, 7, 8 different requests. We know that we want to place a guarantee that the total execution time should be 1 or maybe 2 seconds. If we see that things are kind of getting slow, or if the initial request took 1.5 seconds, then we want to fail early because everything else is just going to be too long. So what this kind of looks like, well, I'm back. So this is a case where it works. So we have the initial request budget of 1 second. We sleep for about 0.5 seconds, which means we still have 0.5 seconds to execute anything we need downstream. This is the case where it doesn't work, where we have the request budget of 1 second. The initial request took about 1.5 seconds, so we just fail the whole request entirely. This works really nicely for us because if we see requests are starting to take too long, we don't consume web workers. One of the worst things that can happen is requests cascadingly get slower, the web workers all get consumed, and you have no web workers to respond to any of your requests. So this has helped us avoid that situation, not just for GraphQL, but for services across the board. The other thing I mentioned, there's no database. The public API owns no data, and that's sort of an aspect of having a pretty complex service-oriented architecture. All the data is coming in from elsewhere. GraphQL provides a pretty flexible way for people to retrieve data whenever they need to. You can use aliases and retrieve 50 businesses in one go, or you can do a search on a nested call and then pull all the reviews and all the photos and everything in one request, which is awesome for a lot of the end user, but internally that can cause a lot of stress on our services. We don't want to get into a situation where we've requested 20 businesses and somebody wants 20 photos or 20 reviews and we're making 60 calls to various services. So we had to add bulk endpoints pretty much everywhere. We were able to take those 60 calls from 60 calls down to 3. We really don't want to accidentally DDoS ourselves internally, so the bulk calls are pretty critical, especially if you're in a service architecture. Access control became a lot cleaner for us. We don't have a separate private API for partners or for special people or whatever. On a normal API, what this ends up looking like is a bunch of if-else statements that basically if has this, then return this, and it's probably 20 or 30 of them depending on what's going on. On a resolver level, this became a lot easier for us to handle. The context the client that I passed into the context way back in the beginning, we pull out into the resolver. We see if the client has custom configs enabled. If it does, we can decide to return. So in the specification, we might want to return an encrypted ID for a specific partner if they have that access. If they don't, we just don't execute at all. Or in a case where we need to return some default, we can do that and just branch off of that. So it's made our entire configuration way cleaner, which I've personally enjoyed a lot because I don't like spaghetti code. So the last thing I want to end on is the community. I remember when I started looking back into GraphQL in November, I was emailing Cyrus a lot. He went to the Graphene library, and I sent him an email that was probably like 1.5 pages long. I was like, I don't really know what's going on. How do we deal with a lot of this stuff? And he was super helpful. He gave us a lot of suggestions on how to implement code, on how we want to approach different problems, on how we want to tackle the implementation itself. He's been very supportive the entire time, and it's, I don't know, something we would have been able to get elsewhere. And then Laurent and I started coming to the GraphQL meetups, and we met up with a lot of Meteor folks. And they've also been very supportive in talking to us through the client libraries. They've put us in touch with other companies. So we've gotten a lot of feedback in general. And then especially when we launched, community was great. People picked up the API, they played around with it, they gave us a lot of feedback, they reported a lot of bugs. So I very much appreciate that people have actually played around with this and been supportive in us building this and actually trying it out. So thank you to everyone who's actually looked at it and played with it. So if you haven't yet, the GraphQL API is still in beta, so I'm still looking for feedback. You can go check it out, yelp.com/developers. There's a button up top that says GraphQL. I think it's pretty easy to find. And shoot me an email if you find any feedback or find any bugs, have any feedback. My email is just tomer@yelp.com. That's it. Anybody has any questions? Okay. Yeah.
Awesome. Does anyone have any questions for Tomer?
How do you deal with paginated resources? Let's say you have like 100 views. How would you load it? How many views at a time?
So the question is how we deal with paginated resources. Right now, we're still using limits and offsets. So you can pass limits and offsets in as arguments to specific resources, and then you just make multiple requests.
Any other questions?
Yeah, how did you choose your performance budget number?
It kind of varies. Right now, I think we just saw an upper bound for what the timing generally is. So within our 99s, we say it's going to execute in X amount of seconds, and we're kind of going with that. Generally, as we add more data, we kind of reevaluate what that looks like just so that we can adjust accordingly. Sorry, so the question was how we chose our timing budget.
What is the limitation on the budget? What's the reason that there needs to be a budget? Is it like machine power or cost or speed?
So the question is, what's the limit, or what's the reason for the budget? The idea is that we don't want to have a lot of requests coming in that are super, super slow. We generally know that some endpoints on our side should execute within half a second. If we see that for whatever reason that endpoint's now taking 1 second, then we're assuming there might be some cascading slowdown across the network, and we just want to fail early instead of tying up all the web workers. Yeah.
How are you handling authentication?
So the whole API is wrapped in OAuth 2. OAuth 2 is not part of the GraphQL API itself. We have a separate endpoint for you to go in, get an access token, and then you pass that into the header, and that's when we do validation.
Do you do much thinking upfront about versioning, or
What's that?
do you have any versioning stuff that you've implemented, or are you just, I mean, I've heard a lot about like with GraphQL, you have a versionless API, but I wonder how it works out in practice. Have you had anything where you need to like change a type and like maybe require clients to upgrade or anything like that?
So the question is how we deal with versioning. We haven't really encountered a situation where we need to do that. The entire API itself is versioned, so this is version v3 of the API. We don't have specific versions on GraphQL itself at the moment. We haven't really encountered any situations where a change is backwards incompatible, and we would require to do that.
Do you have a caching tier sitting in front of your GraphQL endpoint?
So the question is if we have a caching tier in front of the GraphQL endpoint, and we do not. We looked into that a little bit, but that proves to be a little bit hard because most of the requests are really unique, especially anything involving search, where there's any infinite number of combinations of arguments that could come in.
Do you have any information about differences in usage patterns between the GraphQL API and the REST API?
So the question is if we have any information on different usage patterns between the REST API and the GraphQL API. What I've seen so far is people are, they're kind of all over the place. A lot of people do make a search request and then load all the data inside of that. So a lot of people want to load or perform a search and then load reviews, or perform search and load business hours, which is not something we make available on the regular REST API because generally that's kind of a slow request. It's easier to do on GraphQL API because that means they're not requesting other resources or it's not impacting the entire API itself.
Awesome. I think this will be our last question.
So how do you deal with the error? So does GraphQL spec have the recommended format for errors?
Yeah.
How do you go from your some random exception to that format?
So the question is how we deal with errors. On our side, when a data loader or any resolver throws an exception, then it gets caught by GraphQL, and before we return the response, we parse the actual error's body and then handle the formatting there. So I don't know if there's anything too specific outside of that. Yeah.
Awesome. Thanks so much, Tomer, again.
Yeah.
I'll steal those. Oh. Awesome. So next up, we're going to hear from Zane and Jabayo, who work at Airbnb, are going to talk about how they're using GraphQL there.
That's a good idea. Work. Oh. All right, you hear me? Mic's on, all that sort of good stuff? Yeah, all right. Hi, we are from Airbnb. We're gonna talk a little bit about our API really at Airbnb, kind of how we found ourselves in a world that we are starting to adopt GraphQL. It's going to be a little bit of a story of really how it got here and the mobile apps that inspired our current API infrastructure and kind of the direction we're headed and the challenges we're currently seeing. So on that note, I'm Zane. I work on communications infrastructure along with Jobayo here. We are the team that builds a Ruby gem at Airbnb called Graphist, which is our library for doing these things, our data access library, or data access object, DAO, if you prefer. Jobayo and I both started on the mobile teams at Airbnb. I was on the iOS side, and Jobayo was on the Android side about 4 years ago. So that's kind of the context we brought to it. We started there and started building API endpoints out of a need just to have them for the mobile apps, but then found ourselves quickly turned into backend developers. So that's how we stand before you today. And with that, I'll kind of hand it over to Jobayo to tell a little bit more about this context.
Yeah, definitely. Airbnb started off in 2008 as a primarily desktop and web experience. However, if you think about it, the majority of Airbnb is actually an offline experience. Airbnb is not a transactional, web transactional company like Facebook or Google, where you're spending the majority of your time on the website or interacting with the website. Rather, Airbnb is a human experience. You're spending your time walking out and about, exploring the city, or meeting the host, or learning how to figure out how to use a hot tub and enjoying it. And so what that means is that people want to interact with us on the go. And so that actually makes mobile an especially important experience for Airbnb. And so in 2012, we built our first iPhone app and then followed that with an Android app. And people at that point in 2012 didn't really think of mobile as a primary technology. Rather, mobile was just another platform, and likewise with Airbnb, we actually had an entirely separate team just for mobile. And what we did was we built our own mobile-specific API, whereas web had their own separate Rails controller and all that. However, as the industry evolved, we realized that mobile was going to be the future. More and more things were moving to mobile. Users were spending more time on mobile. And what that meant for us was that we had to go mobile first. And likewise, Airbnb API became more in the forefront because it was providing the data for mobile, and it became ever more important. And so where we came from when we first created the API was that API was completely separate for mobile than it is for web. Web had its own Rails controller. But the problems it created was that there was actually completely separate code paths. There were different security things, security problems, and also the fact that if you paid on mobile, you might even get a different price. But then another thing and another big problem for us going forward was that developers had to write twice, once for web and once for mobile. And so we initially had API v1, and in 2015 we started to address this problem by creating a API that would be used by both mobile and web that would address the problems. And the thing that we created is what we call Graphist, which is the Ruby gem and API framework that we created at Airbnb. And I'll hand it off back to Zane.
Thanks. Yeah, so Graphist was actually originally called Restore. Dan here remembers our initial conversations here when we first started embarking upon this journey. Restore was an allusion to the fact that it was a REST-based API. a RESTful API, REST store. It seemed like a good idea at the time. Clearly, the name evolution reflects our evolving philosophy towards data access. But yeah, it was essentially built out of a set of needs that I'm kind of going to walk you through a little bit here. But I think the core principle that I wanted to describe here is that for us, data access is an abstraction. What I mean by that is that there is such a thing as an operation. An operation is defined as an action performed on a resource. So you can think of, a RESTful world as having some sort of verb performed upon a noun. You want to update a listing. You want to create a user. You want to delete a wish list. Verbs, nouns, actions, resources. That sort of thing. But when you look at it, what you quickly start to realize is that REST, GraphQL, even just Ruby code are all syntaxes or languages to express an operation. Each of these things are just different ways of getting towards the same end. It's the same operation at the end of the day. So what we wanted to build, or what we found ourselves building just out of sheer accident, I suppose, is this abstract notion of an operation, of a data access object. And REST was the syntax that made sense at the time, but we realized that GraphQL could just be another portal into that world. So the same framework that we had been building for over years actually became the groundwork that very smoothly transitioned into a GraphQL first approach. In other words, we don't have a translation layer going from one to the next. Rather, the same syntax, or one syntax that constructs an operation with REST, can also be expressed equally well through GraphQL. So the core problem that we're trying to solve here, and ultimately what our framework is meant to build around, is that of a monolith. At Airbnb, like with many companies that kind of started as a scrappy Ruby on Rails shop, we ended up with a monolithic Rails application. In fact, we call it monorail. That's the definition of everything you access at Airbnb. Airbnb.com is connecting to a giant Ruby on Rails monorail application. And that's great when you're 5, 10, 50 developers, but it gets just untenable at scale. Our deploys started getting longer and longer. The monolith needed to be broken apart. So we needed some way to go about that. We needed some sort of abstraction layer so that we could break apart the MySQL databases into services. So essentially what we found is that Graphis could sit at that nexus, that hub between the different ways of connecting to the data stores. So it doesn't matter if you're writing direct Ruby code that instantiates a Graphist operation, or a REST request, or a GraphQL request. Whatever the case, it all reduces to the operation at the end. And that operation has a notion of different resources within it, like a user resource, a listing resource, and these can be backed by different data stores. So it might be an active record or a MySQL table, but we might want to flip it out for a service. So that's the efforts that are being undergone right now at Airbnb, is essentially to start moving those data stores and data warehouses out of one giant MySQL table into individual service-oriented architecture sorts of things. So Graphis actually gives us that abstraction layer where we can flip over a data store, or even do a kind of sampled shadow deploy where we see that we hit both the MySQL table and the service at the same time and make sure that they're both working right, and then finally cut over to the new state of the world. And the important point being that nothing changes on the surface level. The topology for the consumers is unchanged. So they have no notion that the user has just been cut over from a MySQL table to a service. So some of the other things that were kind of important and things that we built into Graphist, or why we wanted to build it, I suppose. Performance, first and foremost, is obviously a paramount concern for anybody building data access or any sort of API. We built in N+1 query solving right into the framework itself, for example, and other sorts of internal optimizations where instead of fetching objects one by one, we can kind of aggregate and coalesce them under the hood. So if we run into 20 requests for users, we can group them all together and throw it out as one request for 20 users. We also thought about things like scale, which is kind of what I was alluding to earlier with breaking into different data stores and services. It's necessary to get off of one giant code base. Graphist also has a whole bunch of monitoring tools built into it that we wanted to think about from the get-go. And this is, a perennial problem, is trying to see where the slowness in your stack is. Something that we are in efforts to solve right now is the fact that any attribute, any field on a resource can be slow for a myriad of different reasons. And it might be provided by some team that another team is consuming. So to have that insight to say that, oh, that request for the listing, the Airbnb listing, was the part that was slow and I know who to point the finger at is very important for us. So to have those tools kind of built into the framework itself that give us insight into what attributes or what properties are being slow is a very good benefit. And finally, and perhaps most importantly, is the notion of security, which is also kind of baked into the framework here. So we have what we call policy files, and policies are essentially whitelists of what can be accessed and by who. The notion being that you write a policy once and it's applied throughout the ecosystem. So my favorite example here is that of a last name. A user's last name is what we would call PII, or personally identifying information. And the definition of who can access that PII should not be repeated. It should not be a concern for each and every developer to have to think about. It should come implicit to the very idea of a user that the last name is guarded by some sort of policy control. So for us, for example, that means that you can only see the last name if you are the same user, or you have an active reservation with that user, one of the other sorts of gates that let you through. But the ultimate user, or the ultimate developer who's using that user, is not someone who wants to think about that access control. The very act of attempting to access last name should trigger that access control. So as long as everybody's playing within the Graphist ecosystem and within this framework, then they get all of those concerns for free instead of having to think about those checks every time they write code. But bringing this back to the kind of GraphQL side of the story here, what we realized was the problem with REST was our notion of how we define the shape of data that comes back. If there's one thing that really bothered us and was really slowing down our development on the API, it was the coupling between front-end and back-end development. So in REST, what we had is this notion of what we called formats. A format is just a name or a string which identifies some array of fields that should come back. So you might have a user format for the user profile, and that format might include the first name, last name, and picture. That's all good and well, but the problem with them is that they're defined on the server. And in being defined on the server, it means that the client developer has to go poke the person around the corner or down the hall to change the server code whenever they want some different response shape back. And that's problematic because of the monolith. Now we have a couple hours to get the code up and reviewed, and we got to merge it, and now we got to deploy it, and now we're waiting on a deploy train, and it might be 24 hours before the client developer can see that new field, and oops, whoops, it wasn't the one I needed, and can you change it again, please? That was a huge cascading problem for us. This notion of having these formats that had this tight coupling between front and back end was just becoming increasingly problematic. So full disclosure, I mean, we are still essentially using REST today. We are just starting to roll out our first real production GraphQL usage. Even though Graphist now supports it natively as an access paradigm, we're starting to experiment with the very notion of using GraphQL first on our mobile clients. So I'm going to talk a little bit about how we've approached it and what decisions we made in that kind of rollout here. So the first thing that I think is kind of interesting to talk about is schema generation. Schema, obviously the thing that defines your API. GraphQL provides the notion of having a schema that defines your API. One thing that is a little bit different about how we approached our schema is that schema is derived from code. Schema is not something a developer writes, rather the developer writes code. The schema comes out of that code. We do this through reflection or introspection upon the code itself. So Graphist looks at the definitions and figures out what the schema is based upon what the developer wrote. We can even do stuff like AST parsing and whatnot in order to grab out comments and stuff those into the documentation as well. So the whole idea here, and we haven't actually gotten that far yet. We haven't actually done the AST parsing to pull comments into the documentation. But the idea being that let's let the developer think in the way that the developer thinks. They write code, they write comments. The schema, the graphical interface, the documentation, all of this are living tools that immediately come out of the very attempt to write the code itself. And we also have some other cool things that kind of come out of that as well, which is that we actually snapshot the schema with each deploy we do. So every time new code is pushed to production, we take a snapshot of the GraphQL schema that was generated with that push, and we are now able to compare those different versions of the schema over time. And this is really useful if you have an incident, for example, where something causes the mobile apps to crash or site goes down, whatever. You might want to trace back everything that happened. And one tool amongst the toolbox is to be able to see what schema changes have been made to the API between deploys. Actually, I think this is a really interesting opportunity if anybody's looking for a good project to work on. I think something that compared GraphQL schemas and gave you a nice visual representation of what changed over time would be quite interesting. Something that we've kind of thought about as a way to be able to say, like, oh, between that deploy and that deploy, I want a good visual manifestation instead of looking at JSON files, what the differences were. So I think the kind of takeaway there is that an API is really only as good as its documentation. And developers, well, me as a developer, I don't like writing documentation. I'd rather write code. So if the code can form the documentation, that makes everybody's life great. And that's what makes GraphQL special here, is that REST and the rest of the world didn't have this sort of community and tooling surrounding it. Graphical, for example, is a living, breathing sandbox / documentation experience. So, and lastly, I kind of want to talk about the challenges on the horizon and really where we're at right now in terms of rolling out our GraphQL endpoints. The first thing that I want to talk about is query registration and the approach that we're taking towards the native infrastructure, native developers using our GraphQL endpoints. So our native infrastructure team is essentially the foundation or framework builders for our mobile apps, as well as the website. They are building on top of Apollo and essentially creating a Graphist client with just a minimal amount of additions that kind of bake in some of the assumptions we have around pagination and primary keys and caching and some basic ideas like that that play nicely with how Graphist is formulated on the back end. So they're currently working on essentially wrapping the Apollo SDK and building out our Graphist client library that connects to the Graphist backend. But of course, it's all just GraphQL in terms of the syntax under the hood and all that sort of stuff. Just very, very minor additions that were relevant to Graphist-specific concerns here, like I said, pagination. And in so doing, some of the things that we're thinking about, like I said a moment ago, is query registration. So query registration is this notion that instead of sending up the whole giant GraphQL query at once, you send up either a fingerprint or a name of that query. It has a couple advantages. The first is that it means that you send up a smaller payload, so you don't have to send, possibly a multiple megabyte large GraphQL query, but you just send up a small identifier for that query. This also gives you a pretty handy escape hatch on the server side, where if the identifier maps to some query, you can block that identifier, you can change the query itself or fix some sort of problem that might have been wrong with it. So hopefully we never have to use that escape hatch, but it's there should we need it. And it also gives us the ability to do code review on the queries that are actually used in production, because we don't really want to open up any GraphQL query to any client in the wild. We want to be a little bit more methodical about this. We want to actually think about what queries are shipped, because we have a lot of scrapers hitting Airbnb, frankly. There's a lot of people who really want to know about the listings and the availability and all that sort of stuff. And any tool that we put out there for them to get as much data as they can possibly get at once, they will abuse. So query registration is a mechanism by which we can lock down and restrict what things can be gathered from the API at once without allowing for just arbitrary access to a billion things at once. We also have other tools that we've built in to attempt to defend against those sorts of attacks. We have something called Cost Defender, which essentially counts the number of leaves in the JSON tree. A lot of this is very inspired by our early talks with Dan over at Facebook on the way to think about the cost of any given endpoint. So we simply look at the number of leaves on the JSON tree, the number of values at the end, and call that the cost of the response. And we ascribe that cost to the entity making the request. And there's a fixed amount of cost that any entity gets per hour. And should they run up against that threshold, should they deplete their gas tank, if you will, then we throw some sort of friction in their face. Captcha, for example, is a way that they can refill their gas tank and get back to good standing. So as we kind of go about this initial rollout, I think it's even just this week that our native infrastructure teams are just shipping the first GraphQL queries to production. Very exciting times. We are essentially trying to benchmark the whole thing. We are looking at REST and GraphQL requests side by side and making sure that they are indeed just as performant as each other, which they should be. Like I said, it all maps to the same operation under the hood. They're just two different syntaxes for expressing the same thing. But the real exciting part is, as long as these assumptions all hold true, and as long as this goes the way we expect it to and hope it to, then we can start playing with the more advanced features. The way we've approached it so far is that all of the endpoints that were built in Graphist and were REST compliant are innately available in GraphQL. But the way I think about it, at least, is that GraphQL is a superset of that. Instead of just having create, update, delete, you have the ability to introduce arbitrary verbs and arbitrary actions into your ecosystem. And that's where developers can really start having fun. They can start implementing new types of requests and new types of actions to be taken on their resources. And of course, there's all different other great things that we might start looking into, like subscriptions and so on and so forth. But first things first. So that's the basic gist of it. My name's Zane, and this is Joe Bio. These are our email addresses. And I wanted to open it up to questions. Yeah, right in the back.
Question. You were talking about performance earlier.
Yeah.
And did I catch you right? You're saying you're aggregating requests from multiple users?
So just to recap the question, it was about performance and the notion of aggregating requests. So no, we're not aggregating requests between multiple users. Rather, what we're looking at is the traversal of the object tree as we render the GraphQL response, or even REST response, doesn't really matter. As we walk the tree of objects that we need to return, then we can encounter different requests that are being made. Let's say that there are 20 listings that need be returned. Well, if instead of making the first listing request, then getting to the next listing request, and then to the next listing request, and issuing them one by one, what we would call an n+1 query problem, we instead can use fibers in Ruby, which is essentially a lightweight version of threads. This is something that we're actually working on right now, actually, and block that fiber and say, oh, we know this is about to call out to a data store, and we're going to block that fiber and wait and see and wait for all fibers to be blocked. Once all of them are blocked, we can say, you know what? There was actually 20 requests for listings. There wasn't one request for a listing. Now we can fetch all of those 20 listings at once. So we solve that n+1 query problem innately to the system, as opposed to requiring a developer to think about this.
Well, sort of kind of the same thing. You're kind of, sounds like you're putting the requests on sort of one bus.
Yeah. I mean, we're putting the requests on one bus, but we're packing that bus as full as it can be,
exactly.
instead of shipping out 20 buses.
That's pretty interesting.
Yeah.
Second is, you said you're doing that the app is offline, or offline is important.
Yeah. So the question was about the notion of offline. That was really meant to set the context in terms of like why Airbnb, in the beginning, it was very much a website. Airbnb was Airbnb.com. Like the mobile app did not arise. The iPhone wasn't even a thing when Airbnb launched. So the transition that we went through was to realize that mobile is the much more important touch point. We are more of an offline experience than an online experience. And increasingly, mobile was deriving the definition of our product. And the API was becoming the more canonical way of accessing data than the website itself. And it made sense then for that API ecosystem to evolve into the abstract data access layer.
So, offline on the client is a challenge. Data synchronization. And I'm challenged getting a sense of how that's even done with GraphQL. Your client is the graphics client.
Yeah.
So, do you guys, to what degree do you manage offline data synchronization? How do you do it?
Yeah, so the question is about offline data synchronization and really caching, I suppose, when you get right down to it. And that's something that our native infrastructure teams are working on right now in conjunction with us. We are kind of more the back-end team here. But that being said, the approach that they're taking is essentially to decompose the response with the knowledge of a primary key on any given object. The ID of a user is the thing that allows you to cache that user. And they can populate their caches with whatever attributes come back. And what they're aiming for is the ability to recompose objects on the fly. So should they need to fulfill a request from the cache, they can do that even if the attributes came back from multiple different responses. So the idea being that if there was one request for a user that had the first name, another request that had the last name, but then you issue a third request that hits the cache and it wants both the first and last name, it should be able to successfully fulfill that request. So that's the aspiration behind it. I don't want to put words in their mouth or make claims about their progress beforehand, but I think that's kind of the general vision of how we approach that notion of caching. But most importantly, they're thinking about it as a primary concern. There's a prioritization in the cache, and we want that data to be immediately available as much as possible, to the extent that if you open up your app and you're in a no reception area, you should absolutely have access to your message threads and to your check-in instructions and all that sort of stuff.
Can you, which is the goal also to be able to mutate and take actions that if you're offline, be able to take them. I want to reserve this, but you're offline and it holds everything to make that mutation.
That's an interesting idea. I don't think we've really talked about that so much so far. I think the idea of making a reservation, it's essentially a deferred request at that point. And I'd have to think about that more if there's any real benefit to having like a deferred request there that just gets sent off when you come online. Maybe it's something that we might want to start thinking about. Yeah.
Basically, is your queryable information also actionable?
Yeah, is it mutatable? Is the cache mutable? not something that we've approached thus far. One thought we have had is the notion of cache warming remotely. I think this would be a really interesting opportunity, is to use, for example, a silent push notification in order to populate that cache with a message, for example. So even if the app is closed, if the iOS app is closed, you might imagine a world where the push notification that sent you the message from the host actually included the full contents of that message, and it warmed the cache with it. So that then later you opened up the app, even though there's no internet, and you never opened the app with internet, it still warms the cache and you can see the message thread. I think that's kind of one of the more magical, visionary things that I would love to see happen, but again, first things first. Yeah, another question.
So a question about your N+1 stuff.
Yeah.
Was that interacting with Active Record directly? Like you said, you're using fibers to figure out, hey, we're about to hit the DB, so instead yield the fiber, lock the fiber, or whatever, and aggregate a bunch of them. Is that like a layer around Active Record, or can you maybe elaborate a little bit on the detail there?
Yeah, so again, full disclosure, this is very much an active project right now. So, do you want to talk about that at all? Because it's actually something Jobao's working a bit on.
Sure. So one way we're doing it is that whenever you want to load something, for example, let's say that a listing has a user. And so when a developer is writing the code to access the user, they would sort of write how to load that user. And so next time you call listing.user, it doesn't actually fetch it immediately. Rather, it creates this deferred load, or this like sort of like a URL. And then the fiber would have that URL. It would block until all the fibers were blocked, and then try and aggregate all of the same URL, for example, all the same URL for a user, and then load that all at once. So it does require a bit of work by the developers to make sure that every field or attribute is written in that way, but then the framework would take care of the rest of the aggregation fibers and loading.
Cool, I see. So is that like significantly different from Shopify's batch loading thing?
I have not looked at that. I can build a little bit on what Jabao just said there. There's one thing that we standardized on here is the notion that each resource is responsible for defining its own what we call data loading strategies. Yeah. And that means that a user never instantiates a listing. Rather, it says to the listing, I have these set of parameters, instantiate yourself given these parameters. And then Graphist, the resource layer, is a wrapper around whatever data store is below it. So whoever implemented that listing or user is responsible for responding to that request for that, that type or those inputs for data loading. And because we sit at the boundary in the framework level between those two resources, we have the opportunity to defer at that point when that request is crossing the boundary between resources. Yeah?
So for your Graphist client, are you porting to native iOS, native Android, and web?
Yeah, so my understanding from the native infrastructure teams, again, trying not to put words in their mouth, is that they are, oh, I'm sorry, right. Are we porting between the different platforms? As far as I understand it, they're just building on the tools that exist there so far. So if I understand correctly, Apollo has a native SDK for Android and iOS, and also, of course, the web library, and we're just kind of building wrappers around them that add our additional business concerns. So I don't think there's any porting going on, per se.
Does Apollo have an SDK for iOS? Does anyone know for sure? I thought everything was JavaScript. Okay.
No question or answers in the room? Yeah?
Yeah, I got one more question. So with your security stuff, the policy stuff's pretty cool, and I imagine you can have like, I guess you said that you can check permission at like a field level on each like object or whatever. Does that mean then that your GraphQL schema has like a lot of nullable fields in it because maybe the user doesn't have permission to see something? Or do you handle that in a different way?
Interesting. So the question is about policy checking and the notion of how we gate access control, specifically with regards to the schema, yeah?
Right. It feels a little unsatisfying to have an object where everything's nullable because like maybe someone doesn't have permission to it. Because then the client is now responsible for checking like if this thing is present all the time.
Yeah, so the question of do policies affect what you see in the schema is actually a discussion that we're having with our security teams, like literally right now. There's an email thread between me and our security teams of, is it important for us to lock down the schema definitions for clients? Is that an attack vector that exists? Is it a bad thing if somebody knows that this field is even accessible or exists in the API? Because certainly there are endpoints that are by design admin only. And once some third party sees our schema, is it a bad thing that they know about that endpoint? Or how do we represent it to them if it's not something that they can access? Not a solved question at the moment, but I think we're kind of agreeing that if a developer writes a schema that has an attack vector in it and exposes some sensitive information about the stack, that's probably a bad thing. Like, you have to assume that schemas are going to become public knowledge at some point or another. Like, people are going to know your API in some way, shape, or form. So if you're building your security under the assumption that nobody's going to know that it exists, that's just security through obfuscation, or security through obscurity, not true security. Yeah.
So if somebody requests some data from the schema they don't have access to, do you just straight up forbid the full request, or do you return a partial piece of data?
If somebody requests access to data to which they do not have access,
it's a mix of data that they do and don't have access to.
Yeah. So our current approach is that we do blow up the entire request. This was by design in the RESTful world, and that was largely in a place where there was only one operation per request. It made perfect sense. You do not want to continue down the road of continuing that operation. Like, it should just explode and throw an exception, and the whole thing should end. But I can see an argument, and I think we are starting to agree, that if you have, say, multiple top-level function calls or multiple top queries inside a GraphQL request, well, maybe one of them threw an exception, and it should end, but maybe the other two should proceed. And I think that's reasonable. Still trying to wrap our head around the possible consequences of that, because what if there was a dependency between the first and second one? I don't think it's so much a problem with queries, but mutations might be bad. If you expected the first to succeed and then the second relies upon that success, you could find yourself in a bad state. And we very quickly end up in the realm of transactionality and rollbacks and all that sort of stuff. So I think that might be kind of dangerous territory. But that's just, off the cuff.
Awesome. Thanks, Zane and Javaya. Cool. So we're actually going to break for about 10 minutes, and then we'll see you back to hear from Lee about GraphQL subscriptions.
different mobile clients. Because we have one GraphQL and one Facebook post that everybody can watch, and it's unversioned and it's every version of the So you can get a lot of mileage out of it. How you evolve deleting things like that. It really just removes that game points that are like, if version between this and that, remove this here. This one. Yeah, and then like how do you like things too? So if you want to so yeah, I mean, as much as you can. Slow as you can use.
Actually, no, I love what we're doing. It's because the rule ends up being
So like, there's chunks of double dozens.
and then you add
Most new code. A lot of the
the idea is like you can say like design if user is generic, like not logged in.
Yeah, and I see that. Well, it's really modern. Yeah.
So it's like how it functions with
That like actually builds. Yeah. So how would I get that interface where I really nice that I have that say like it's not a like React writer
allow it to design
so if I have like a type annotated function and then I have like this type annotated say like the relay they're still source, right?
and then I have an executor serial executor.
Yeah, so something that like, so obviously the modern executor is still pretty fast. One of the things that we're
We're going to get started again in about 2 minutes. So, yep, wrap it up, and we'll see you soon. Okay, everyone, we're getting started again. So take your seats. Hey, everyone, we're going to get started here in about 15 seconds, hopefully, depending on how fast you can get back to your seats. Excellent. Thank you. Sweet. Okay. Hello again. Next up, we have someone who almost needs no introduction at this point, Lee Byron, who is one of the co-creators and current maintainers of GraphQL, the spec, and the reference implementation. Previously at Facebook, he's worked on Immutable.js and React, amongst other cool, snazzy things. So welcome, Lee.
Thank you. Yeah. All right. Let me plug all these bits and pieces together. How many people here have not heard of GraphQL subscriptions before? Cool. This is good, because I'm going to go deep, so I'm not going to give like a high-level overview. Let me make sure that this is not mirrored. You would think that they'd figure this stuff out. Every time you plug in a projector, you got to redo all the stuff. Come on, Apple.
Windows figured it out.
Don't tempt me. All right. Hello, everybody. My name is Lee. I'm going to talk about GraphQL subscriptions today. Specifically, how do they work? Do they work at all? Let's find out. I have a handful of slides that show code, but in my opinion, the code itself is not actually that novel or interesting, and that's a good thing. And what's actually really interesting here are the core concepts and the abstractions that are involved and how we can combine those things together to create super flexible architectures. Another way to kind of like phrase this presentation is that we used to have this interview question at Facebook. We don't ask it anymore, so I think it's pretty safe for me to divulge what it is now. Where you would say, you're sitting at your computer and you type in facebook.com and you hit enter, tell me what happens. And like a bad answer is facebook.com loads, and a good answer is, well, first an electrical signal goes from your key to the keyboard bus. Wait, how much time do I have? That's a good answer. So that's kind of what I want to do here is like start at a super high level and then start to like unpack the abstraction. And at the end of this, what I want to get to is
kind of some like real world takeaways that you can have on how to actually build one of these things and scale it. And that's pretty far away from where we'll start. So let's see how far we can get. Let's start with the most abstract possible definition of these things, the spec. So this is actually really exciting because this landed in the spec like a week ago. There's still some details to work out, so this is not a released draft of the GraphQL spec yet, but here we have it. So if the operation is a subscription, then the result is an event stream called the response stream, where each event in the event stream is the result of executing the operation for each new event on the underlying source stream. That makes sense. Here's the key phrase, event stream. This is super clutch. This is the whole deal. This is everything about what makes GraphQL subscriptions. So let's start there. Event streams. So event streams are a conceptual model, an abstraction. There's lots of different ways to implement these things. That's part of why we talk about them in the spec in terms of a conceptual model, is we want people to be able to implement them in lots of different ways. We don't want to like enforce that you use like RxJS or something like that. So let's first look at this as a conceptual model, then we'll show a little bit of code. So an event stream is a stream of things that happen over time. Hopefully obvious from the name of this thing. So you get these things that come in like this. And we got a couple things here. Oh yeah, and then at some point it can close. So we have some concepts. This thing is an event stream. This is a piece of data, an event that happened on that event stream. And at some point, most event streams complete, which is basically their way of saying no more events will happen on this stream. Some other stuff can happen. So you could be happily getting some data, and then all of a sudden you get an error. And errors are always followed by a completion. And so it's important that we can represent both a piece of data flowing through the system and an error flowing through the system, because we might want to handle those two cases differently. One other case that we want to make sure we cover in this abstraction is the idea of a consumer, right? So event stream has these things that happen, but if nobody's listening, then kind of what's the point? So we have this consumer. So as these events are coming in, they're getting consumed by the consumer. And at any point, not only could this event stream close and tell the consumer, hey, I don't have any more events for you, but also the consumer could send a cancellation, which basically says, even if you had more things to send me, I don't care, please send me a completion. So that's the last major thing that can happen with event streams. So event streams are pretty cool. You can do a lot of interesting things with them. One super important concept to make sure we get out front is an event stream mapper. And we actually use this in the definition of GraphQL subscriptions. So an event stream mapper is cool because what it does is it takes in an event stream and it returns a new event stream. And then as events come in, they can kind of get reshaped and come out the other side in the other event stream in a different form. So a mapper is kind of like a function. It's somewhere in the monoid family. I don't understand that stuff, but I'm pretty sure that's half true. Right. If you get an error, those things just pass through. Those don't get mapped. That's almost always true. And then completion events also go all the way through. So when the event stream that you're mapping over closes, you also close your mapped event stream. So that's an event stream mapper. So these are the two kind of building blocks that we'll use to define how this stuff works. So let's take a break and look at some code. This will be actually the only code in the whole presentation. Is event streams, if you've kind of been around the block, you probably read some code where you're like, I know what event streams are. I know I've written some node streams. Very cool. Node streams are an implementation of this exact idea. So you can create a stream. And then you can say, hey, when I get data, I want to do something. And if there's an error, then I want to do this other thing. And then once this thing ends, then I want to do that thing. And we also have this concept of cancellation. That's also there. And I don't have a line of code up here, but there's a concept of through streams, which is basically the idea of a event stream mapper. So we have everything we need with node streams. So that's one way that you can implement this idea. Another one is Rx observables. So if anybody who's messed around with RxJS or RxJava or RxSwift, observables are another implementation of this exact same abstraction. So you can create an observable, and then what you do is you subscribe to that observable, and you can pass some callbacks. So you can say, here's the callback to call when you get some data, here's the callback to call when you get an error, and here's the callback to call when there's nothing left on a completion. And then there's also an API for cancellation. So again, we have all the pieces that we need. And if you look at RxJS or any of the other Rx libraries, they come with not only map, but like a plethora of other tools that you can use to operate on these things. Another one that should be familiar to JavaScript developers, I hope, because it was part of the ES6 spec that launched 2 years ago now, is iterators. So iterators are cool because they're almost this concept, but not quite, and I'll show you why. So iterators, you can create them, and then what you do is you say, well, I want the next piece of information, and then you get back this kind of tuple. You can ask, is it done or not? And then you can kind of decide what you want to do there. And then if it's not done, then you usually have a value, and you can do something with that value. Otherwise, it throws an error when you call next, and you can do whatever you wanted to do with errors. And then we also have this idea of cancellation. So this is not specific to all iterators, but any iterators that are generators. So this subclass of iterators, you can call this return function, which will cancel it. So this is cool, but everything we talked about so far is this idea that events will kind of be pushed to us. And here we have to call next, which means we're trying to pull events out and get them immediately, which can't always work. Sometimes our buffer might be empty, or we might just be waiting. And we can't block in JavaScript. And actually, we can't block in a lot of different programming languages. So this doesn't work. But good news is that there's a new proposal to JavaScript that's super exciting called async iterator that kind of gets around this problem. So we have all the pieces that we need now. We can create one of these things. It kind of works like an iterator. We call next, but when we call next, we get back a promise. And when that promise resolves, then it resolves to the same tuple where we have done. We can see if it's the completion. And if it's not done, then we have a value that we can use. And then since it's a promise, we can also capture errors and have a callback there. And then we have the same exact API for cancellation. So this is cool because it's the exact same API that we wanted, that we got with node streams, that we got with observables. So why would you use async iterators instead of observables? Observables are cool. This got specified, but who cares? The answer is because it's becoming part of the JavaScript ecosystem at a core level. That means we'll have new syntax for working with these, so they'll feel very, very familiar to the actual programming language of JavaScript, which is super cool. So we can replace that code with some new code that does exactly the same thing. This time we can write a special kind of for loop called a for await loop. And what this will do is it will do that like .next, .then kind of handling for you in the background. And every time a new message is pulled and resolved, then your loop iterator will call, and you can do something with that. Otherwise, this thing will throw. You can catch that error. And then you can use the really nice try, catch, finally loop to handle your completion. So this is pretty cool because this reads like standard synchronous code execution, but this is actually syntax sugar for the exact same slide that I showed you before. Another cool thing is not only is it syntactically baked in to be able to operate on these things, but there's also syntax for making them. So if I wanted to make this create async iterator function that I just used, it might look something like this. Now there's some like weird decorators happening on this function. This is definitely not a normal function. It's an async function, which you might have heard a little bit about if you've messed around with async await, which usually return promises. But it's also a function star, which is a generator function, which has actually been around in JavaScript since for like almost 10 years. Like Firefox has had this thing forever and ever and ever. So there's been an open question for years in the JavaScript committee of what happens when you use both of these two things at the same time. And for a long time, the answer was, oh, it's easy. It's a syntax error. Don't do that. But we think this is the answer. So this is stage 3 in the JavaScript process, which basically means one step away from being totally baked into the spec. So if you use both async and star, you get an async iterator. And that's cool because you can both use await, like you could use in an async function, and you can use yield, like you would use in a function star generator function. So yield is cool because every time you yield, it pushes out another one of these events. And you could do that as many times as you want. You could do this in a loop. You could connect this to some other random service and have that do these things. You could operate on them. This is super cool. So you can kind of mix and match the worlds of promises, generators, and async iterators all together in syntax. So this is awesome. I'll get back to why this is exciting kind of at the end of the presentation. All right, GraphQL subscriptions. We've got our abstraction down. We have everything we need to understand GraphQL subscriptions, right? Almost. First, we should have a super quick refresher on how GraphQL queries work. So with GraphQL queries, there's 3 important steps. We've got parse, validate, execute. And what happens is when we get one of these requests in, parse will turn it into a syntax tree. Syntax tree will be validated, usually against your schema. Make sure that you're not asking for something that doesn't exist. You haven't done something totally squirrely. That goes to the executor. Executor will turn that into your payload, send the payload back to your, does that. It's got to take a little bit of time, and then off it goes. So with subscriptions, this should be pretty easy, right? Like we're just going to take this execute box and swap it out with subscribe box. Done. Except that before, we were just kind of returning this response, and now we're not doing that anymore. So what's going to happen here is instead of returning a response, we're going to return one of these event streams. So we're going to do the same few steps, but now once it gets to subscribe, we're going to immediately turn one of these event streams. And now we can start issuing these yielded payloads, or event data along this event stream and send all of those to the client. And then, of course, the client can cancel us. We can close their event stream. So this is kind of it. This is how GraphQL subscriptions works. But of course, I promised you that we would slowly start to unpack the envelope and see how far down the rabbit hole we can go. So what's actually happening here in subscribe? How did we go from having a valid query to having an event stream? How did that work? Well, let's take this box apart. So subscribe itself is actually defined in terms of two operations. Create source, and then it's one of these mappers. So create source is this thing that takes in this validated query and returns an event stream. And then our mapper is going to map that to a new event stream. That way, we can send in one of these events. And I can't see my screen. And then the thing came out. So how's that work? Well, the mapper is actually going to map these event streams by using the existing GraphQL execution function. So we're going to recycle that from before. And now here's what's actually going on, is that event goes down into the executor. That's going to do whatever it's got to do, send the response back up, and back off to the client. All right, now we have to add our consumer. The consumer is the client. And let's not forget that these steps still exist. So now we actually have a pretty good picture of all of GraphQL subscriptions with this box unpacked. So let's kind of see this all in action. So we've sent a request, parsed it, validated it, put it into create source. Now, create source has an important job to do, which is having received that request, it actually needs to do some work to figure out, well, what is this source event stream that needs to be returned? So it's going to do some work, then return that event stream. The mapper is going to return its own event stream back through to the client. And now that it's done that, we can start to send all these events through, which are going to the execution function, which is going to work on these things, send them back to the mapper. The mapper is going to send them on to the client. So this is kind of a complete picture of what's happening when we use GraphQL subscriptions. But maybe there's more. All right, let's see what's happening. Ah, yes, of course. If we cancel, the cancel goes through the mapper. We already saw that from abstraction before. Create source closes. And this is actually a great opportunity for whatever the original source was that was created by create source to do any kind of cleanup. So say you had opened a connection to a pub sub service. Getting that cancellation might be a good opportunity to close your connection to the pub sub service, something like that. So that's it. That's basically, as far as we've gotten so far, is what is written down in the GraphQL specification, the clauses and all the defined algorithms. I basically have already covered just using kind of colorful boxes and arrows. But what this leaves us with is sort of some unresolved implementation details that we're responsible for filling in. And that's very much on purpose. What the spec wants to do is only paint the abstraction for how this works. That way we can fill in the blanks however we need to build kind of a myriad of different kinds of services. So first, let's look at this create source box. What are some of the things that we might do to implement that? Well, a really obvious one, and one we talk about all the time, is we'd want to subscribe to a pub sub topic. And this was the original motivating force for building GraphQL subscriptions at Facebook a couple of years ago. When we talk about it publicly, we talk about GraphQL subscriptions as a way to put GraphQL on top of your pub sub system. So obviously, this is a great place to start. But we could do other things. Another thing we might want to do is maybe watch for database writes onto a database that will give us a live stream of writes that arrive. That way, we could trigger queries that say, hey, somebody just edited this thing that you're subscribed to, so I want to tell you about that. We could process a Kafka stream. Kafka is a super cool library and framework that if you haven't checked that out, you probably should. It's a pretty awesome way to build a microservices architecture and then have this sort of real-time system working within it. You could do something totally different from that, right? You could just tail a file. That's fine. Or you could listen for incoming HTTP calls. I don't know. Like we got an endless set of things we could do here. We could listen to like incoming stock prices from a stock ticker, whatever. Like anything that's going to tick data at us at a reasonable rate of time is a totally reasonable implementation for this function for creating a source. So if you put this stuff back, there's kind of another problem here that I glossed over so far, and that's the internet probably needs to go somewhere, right? Like we've got this GraphQL thing. We said there's a client. Like, how does this work across the internet? The GraphQL spec leaves this up to you, but there's some nice ways to think about this. So the way that we think about this is that between GraphQL and the client, there is this thing called a transport. And in typical GraphQL, this is usually just HTTP, and this transport's pretty simple, right? Like a request comes in, it might be a GET request or a POST request. You forward that on to GraphQL. GraphQL's like, here's some JSON to give you back, and you're like, cool, this will be the body of my HTTP response. So that's a pretty easy transport, but when we get to subscriptions, transports can get a little bit more complicated. So transport's really two halves. There's the server's half of the transport, and then there's the client's half of the transport, and then there's some protocol messages that are going to happen back and forth. So for HTTP, this might be TCP packets flying back and forth. But for subscriptions, this might be something else. So now where we are is this client's going to send us a request. Once we've gotten that request, then the client side of this transport is going to be like, all right, I need to talk to my GraphQL server, so let's open a connection. Once that connection is open, then we can send a packet that represents what we want to do to GraphQL. And then on the other side of this transport, it's going to turn into something GraphQL understands. GraphQL's going to say, cool, here's this event stream that I want to give you. Our thing's going to then wrap that up, send these packets across. And now every time we send one of these events, our transport has to come up with some way to serialize that, send it in packets across the internet, put those packets back together, and then hand those back to the client. So there's a lot of really pretty complicated work that needs to go on in order to make this actually possible. So let's take a quick look at this thing. Maybe what are some ways that we could implement that? Well, one that we talk about a lot is WebSockets. WebSockets is pretty cool because it's kind of built into almost every major browser at this point. So that's a really good one. Some other ones are other like messaging protocols. So this might be MQTT or ZeroMQ or RabbitMQ or something like that. We actually make large use of MQTT at Facebook. It's a pretty major client-side transport for us. Maybe we want to post to a webhook callback. This is one that I think gets undersold in the conversation of subscriptions. I think GraphQL subscriptions and API webhooks are like a match made in heaven. That when you sort of subscribe to a webhook, you might send a GraphQL subscription request along with that, and then also provide the HTTP callback URL that you'd want to be hit, and then we can kind of post messages to you as they come in. So that might be a way to do this as well. Or I don't know, send an email, or like literally any way that you could kind of transmit messages, multiple messages over time. It's all up to you. So, don't let only the handful of things that are already stuck in the world of asynchronous message sending be the end of your investigations. So now that we've seen kind of the pieces, both at the abstraction layer and the pieces that we need to implement for ourselves, let's talk about some of the problems that we're going to find when we actually want to productionalize one of these systems. So probably the first problem you're going to run into is your client's going to want to send more than one subscription. So a really clear example for us at Facebook is listening to the number of likes on a story in your newsfeed. So as you're scrolling through newsfeed stories, we're actually creating and unsubscribing from subscriptions as you scroll. That way, whatever's in the viewport, we're keeping those, we call them our feedback interfaces. We're keeping the feedback interface as up to date as possible. The thing is, as you're scrolling and another story comes in and you're creating one of those, well, you've already got this whole end-to-end thing hooked up. So what do, right? Like, do you make another one? Do you open a new WebSocket and like call through to GraphQL? I guess you could do that, but I think it's pretty obvious why this might be not the right answer. Eventually, your client's going to run out of sockets. That's going to suck. Your server's going to have huge incoming load. You're going to have one user tied to multiple servers if you've scaled the number of machines you have. This is probably not the right answer. So what is the right answer? So I think multiplexing is a really cool tool that you can use to do this. So the way that works is that your transport needs to understand that there might be multiple things happening on that transport at the same time. So usually your browser is actually doing this for you. So a browser will multiplex requests using the URL. So if I say, I want to load these 10 images, and then the server starts sending me back responses, and it's like, by the way, this is a response for this URL, and that's the response for that URL, that's multiplexing. I know as each of these packets are coming back, which resource they belong to. So I need a similar solution here as I want to say, hey, I need a new connection to my transport. The transport says, cool, I already have one of those open, so I'm going to go ahead and send to my existing transport a request for a new subscription. That's going to send to GraphQL. Now, GraphQL can have two open event streams pointed at the same transport. And now, as we send these things back, we can kind of wrap them up in with a little bit of metadata about what stream they came from. That way, on the other side, we can deconstruct those back into the appropriate streams. So this is an important thing to get right. It's one of the first things you'll probably bump into. All right. Oh, yeah, I talked about multiplexing. So scaling. So far, everything we've talked about, all of our boxes, kind of assume that everything's happening on one machine. Now, that might be OK if you're at a hackathon, you're making something really quick. But if you're lucky enough to have thousands of users even, tens of thousands of users definitely, one box is not going to cut it. You're going to need to scale. And this makes things a little bit tricky, because before, if we're only handling queries and mutations, those are stateless. So the request comes in, you resolve it as quickly as possible, you send the response back, you close the connection, you get out of there. You can handle lots of incoming requests. And today's modern boxes with good software can handle tens of thousands of requests pretty easily. But subscriptions are long-lived, so each active subscription is going to count against the number of sockets that you have open, or the number of work that's happening on that machine, or amount of state and memory that's holding on to. So you're definitely not going to do tens of thousands of requests a second on a machine that's responsible for scaling. So one of the first things that you might want to do is chop up this server-side diagram into two pieces. So you're going to say, I'm going to take the execution engine, put it in its own service, and then I'm going to take everything that's stateful and keep it in a stateful service. So now you have these two pieces. That way, if you want to scale these things up, you could actually have many execution services. And as you're getting these packets from your source and you want to run them, you could just send them to whatever execution service happens to be available to do some work. And then if you need to scale up the number of subscription servers that you have, you can kind of do that independently. So if you realize, oh man, I get tons of incoming queries and mutations, plus this incoming subscription load, I need 100 nodes to handle that. But subscriptions is comparatively lighter, but each box only handles so many consecutive connections, so maybe I need 10 of those. So you can scale these independently of one another. That's going to be really important. The next thing is, this create source, it's going to talk to something, right? We're going to talk to some database or pub subsystem or stream publisher or something like that. And as we scale the number of boxes that we have, if we're hammering one of these things, eventually that thing's also going to run into scaling problems, right? And again, this is maybe not that hard to scale if you're only doing queries and mutations. I think it's pretty easy at this point to understand how read slaves for MySQL work, or actually a lot of cloud services just have kind of you don't even think about it, they just scale your read-only database reads for you. But with subscriptions, this gets a little bit trickier. So as you start to scale up the number of machines that you have for storing information, you're not just storing information, you're also pushing all these events around. So now that you have all these things happening with events, maybe the source of the event happened on this box over here that you're not paying attention to. And so you need to make sure that all of these boxes are talking to each other so that that box can say, OK, something's happening, and then push things back up. So making sure that you're thinking about scaling all of these three pieces independently is also tricky. So another thing that you might bump into is throttling. So throttling is important when you're not sure what the rate of these errors is going to be. So this got really important for us at Facebook. Let's go back to our diagram here. Going back to my example from before, listening to the likes and the feedback on a story. So if you're scrolling through your newsfeed on Facebook and you see some posts from your friends, well, if somebody likes your friend's post or writes a comment on it, you probably want to get that information in a timely manner. And you really don't want to lose out on that. If stuff's happening, you want to see it because you're looking at it in your newsfeed. But if in the process of doing that, you scroll by a post by like Lady Gaga or Barack Obama or even Mark Zuckerberg, then those posts get like hundreds of likes a second. Like, it's crazy. You do not want hundreds of like events getting pushed to your device. Like, it'll warm up. Your battery, you'll watch it like 60%, 59%, 58%, 57%, like, oh no, what's happening? I hate Facebook, and you'll close the app, right? So that's bad. What we want to do is throttle these together, so if the rate exceeds some limit, that we start batching them together in a way that is still compatible with our GraphQL definition. So at Facebook, what this looks like for us is that we're just getting lots of these events pushed through, but then our source has a throttling service that makes sure that if these are coming through at a fast rate, that we're making sure that we're only then pushing them back through the GraphQL service at a reasonable rate that it can handle, so that it actually is pushing to the client in a way that won't melt the client. One last topic I want to cover is quality of service. So with quality of service, have you guys heard this term before? It basically means if I push you a packet, what do I want the guarantee to be? I could say, I'm going to push that packet to you once, and if you missed it, tough luck. Or it could mean, I'm going to try as hard as I can. If I haven't heard from you in a while, I'm going to call you again. It's like an overbearing mom. Like, that's quality of service too. Like, you know, dad who doesn't care, quality of service 0. It's like the gamut right there. Let's go back to our diagram. OK, so here's the problem. Everything's been working well so far until, like, our client just walked into a subway or drove through a tunnel, or like something happened and we lost them. This happens all the time. But even worse is we just got this event. It went through the whole system. We did all this work, and no one's there to listen. So now what? Well, I don't know. Like, this is for us to decide. Maybe it depends on the particular subscription. Like, for like counts updating, maybe it's OK for those to be dropped. But for a new message coming onto a message thread, probably important to hold on to that. So if our client comes back and they reconnect, maybe within a reasonable amount of time or whatever, then we can send that message back on. That's something. Cool. So that's kind of it. That's GraphQL subscription in a nutshell, plus a handful of these things that you might encounter when trying to actually build one of these things in a productionalized manner. So I want to talk a little bit about where you can find these pieces if you want to start playing with this stuff and building it now, since a lot of it is pretty new. First, I'll draw this box here. So we usually talk about creating a source and how that source maps to your executor as kind of one box. That's what we talk about as GraphQL subscriptions. So this piece here is part of GraphQL JS. So we actually released a, I would say, like a technical preview of this. There's still some last-minute details that we're kind of hammering out. So expect the API might change between now and the next version of that. But you can start playing with the early version of this. Of course, GraphQL JS already has parse, validate, and execute as part of it. So this subscribe piece with these two utilities is new. That's there. For the client, there's, of course, Relay and Apollo are both clients that understand subscriptions. And I should also say that you don't really need to use either of those if you're building something that's doesn't need the complexity that either of these two clients bring you. They bring lots of features, but if you don't need that, something simpler is great. Again, reiterating, WebSockets is basically available to you on every major browser. So if all you want to do is say, hey, I'm going to consume WebSockets and then do stuff, that's great. Just go nuts with that. Then I didn't mention, but in GraphQL JS, the way that we've implemented these subscribe boxes is with async iterables. So when I talked before about how async iterables is becoming part of the JavaScript ecosystem, that's important to us because we want to be building a reference implementation that is going to grow well with the rest of the JavaScript ecosystem. So we've kind of gotten on the bandwagon early with async iterator. And that means as you're implementing these pieces, rather than doing something that's GraphQL specific or a certain library specific, you can just write something that is designed to work with any kind of JavaScript library. So if you're building one of these transports, this is one you can use today. It's called Subscriptions Transport WS, which stands for WebSockets. That's written by some of the engineers at Apollo. That will take in an async iterator and return you WebSockets. And it's got some additional logic that will make sure the right steps happen with respect to parsing and validating your GraphQL queries. And then, of course, there's the sources for these things. So there's a bunch of community-contributed implementations of these that will give you an async iterable for calling them, which is super cool. It means that not only can you use these with GraphQL subscriptions, but it's actually a really nice API on top of any of these kind of eventing systems. This one is really great if you're using Redis as your kind of pub subsystem. GraphQL Redis subscriptions will do this for you. And as I kind of mentioned, all of these things ideally will start to evolve with the JavaScript ecosystem and implement async iterators. So we should not have to wait for people to specifically build these for the GraphQL system. We should just hope that people will build these for async iterators in general, and they'll just happily work with GraphQL with hopefully very little additional work from us. So that's it from me. Any questions on this stuff? Yes. Oh, thank you. Yeah, I pride myself on my animations.
So one of the cases that I struggled with when I thought about these subscriptions is duplicate data. So if I make a traditional GraphQL query and I say subscribe to, if I query for a user myself and then I query for a game which has users in it, and I'm in there as well, I get all that data back. Both of those instances of the user and myself are the exact same. But then if I have two different subscriptions that contain myself as a user in both of these locations, and I get data back from this kind of asynchronous transport or whatever, my application can get into a state where it has myself as a user in two different states. So is there any effort into like deduplication of data, or would you just design the application differently?
So let me try to rephrase your question as briefly as I can. As you're getting data from lots of different sources, how do you dedupe that in a way so that you're not getting inconsistencies? I highly recommend checking out Relay Modern or the Apollo client, which that's basically their #1 job, is the deduplication of data and making sure that whatever the most recent data that is seen is the data that is displayed everywhere, no matter where you got it. So both Apollo Client and Relay Modern both implement this idea. So this is super cool when used in context with subscriptions, because what you can do is say you're Facebook and you're building newsfeed and you're scrolling through these stories and you're subscribing to comments. And one of the things that you want to be aware of is if somebody changes their profile picture. Actually happens all the time. People will be in the middle of a thread and they'll change their profile picture and they'll hop back and they'll continue to chat. It's super cool when you're doing that, someone changes their profile picture and all of a sudden it shows up in the UI everywhere. That's because one message got pushed. We include that because it's relatively cheap to include in that response. We can look at that, we can compare it to the one we had before, notice that it changed, and then refresh any part of the UI that might have that person's profile picture in it. So that's one way to do it. Another way is trying to handle that at the transport layer. So one of the presentations at GraphQL Europe talked about using GraphQL subscriptions alongside a GraphQL query to say, maybe I want to fetch all of something that exists at the time, and then I want to open a subscription for new ones that come in. So say I'm building a game, and I want to know all the players in a game. So when I show up, I want to know who's here now, and so there's 10 players, and now I want to open a subscription, so any players that show up after I did, I get notified that they joined. So there's this sort of temporal gap between running the query and having the subscription set up where you can kind of lose on either side, right? Like you either have this temporal gap where you're not listening and someone might join the game before the subscription set up, and then now you have this person in the game that you didn't even know was there and you've lost some information. Or you set it up where you send the subscription up first and then you send the query, and now you might get duplicated data, right? You might get a subscription payload that says somebody's joined the game, right as your GraphQL query is coming back that says, hey, this person's in the game. You're like, I know, I just got a subscription about it. So at worst in the case where you have the gap, you have missing information. Sort of mediocrely at best, you have the case where you're getting multiple payloads for the same information that you're getting multiple times, which is not as efficient as is optimal. And doing it at the transport layer might be a way to solve that. So one of the tools that we've built at GraphQL, or at Facebook, is called GraphQL Batch. It lets us send multiple queries, and we do not have this feature yet, although I imagine at some point, if we run into this exact scenario, it might force us to try to build it, is sending both a query and a subscription at the same time, and then make sure that those can execute in sort of an atomic manner on the server where we can control for the temporal divide. But honestly, we haven't actually run into that case, and it's more important to us to not miss data than it is to get slightly duplicated data. And so if we're getting, one push notification more than we need, that's usually okay for us.
So, little caveat. What I was thinking is that if you have these two subscriptions, you might get an update for the user, and then your user will be in two different states. But I think your question earlier, or your response earlier,
Yeah, avoiding the two different states, you want to use something that will normalize your data, which is Relay or Apollo client. Yeah. Other question? Yeah.
So if you have one definition with two subscription operations in it, like for instance, listening for likes and then listening for profile picture, you set up your event source that you're listening to two different streams. One of the events comes in, you re-execute it. What are you doing with that event only applies to one of the operations?
Yeah. Great question. So to repeat, what happens if you have a subscription that has more than one subscription operations in it? And the answer is it invalidates. We don't run it at all. And this is actually, it's a great question because it was one that was sort of one of the core questions that we were trying to answer as we were going through the spec process. And it turns out to be a can of worms. There's all kinds of super weird, you're scratching at the right first piece of that can of worms of whoa, what do you do with this other thing that's sitting over here that you might have an event for? What happens if you get two events simultaneously? Do you merge them? Oh, I don't know. This is hairy. And so the answer was, let's punt. And so to punt on that, we couldn't leave it undefined because that would mean that every server would kind of come up with their own definition for what that meant and handle the edge cases in their own way, which would mean skew between all the different servers, which is something that we'd like to avoid. So instead, we decided that should be invalid. So if you have more than one operation in a single subscription request, we just say you can't do that. And then if you want to have multiple ones, the answer is, use multiplexing on your transport, open up multiple subscriptions. It's not going to be additional resources on your server because you're still going to share that one connection. You're still going to create, two source event streams. It's going to set up the same amount of resources, but there's going to be much better definition about what can happen and when and why. Other questions? Happy to answer non-subscription related questions as well if people have those too, but any others? None? No questions? You guys are easy. You're just waiting to drink more beer.
I think that is approaching the end of our meetup. But thanks so much, Lee, for coming. That was awesome. Yeah. Also, I'm going to throw up one slide that I forgot about before in my introduction. It's not really important, but I'll put it up anyway. Essentially, what would be awesome is if anyone here who's interested in talking more about GraphQL at this meetup, at GraphQL SF, any other events that we do, or if you want to blog about GraphQL, or if you want to contribute to any open source projects and don't know where to get started. You can either follow us on Twitter or just tweet at me. I'm kind of a good orienteering type person in the community, and I'm really excited to point people in the right direction and edit any blog posts you throw at me, whether or not they end up on our blog. So, yeah, hope to hear from you. And thank you all for coming. Hope you stick around and ask any last questions you have of our speakers. Feel free to grab any food that you would like to take home with you. This is something that I always say at the end of our meetups. And otherwise, I hope you join our meetup if you haven't already, and hope to see you next time. Also, thank you to everyone who's joined us on the live stream. Awesome. Bye-bye, guys.